Can you guys hear to my voice? If you can hear to my voice, then please write something in the group chat. Otherwise, it will be very difficult for me to understand. Hello? Can you guys hear to my voice? Good. Then should I start? Okay, fine. When you guys say me to start, then I'll be starting. No hurry. I'll be waiting till 8:15 maximum. After that, I'll be starting. Okay? Then please get ready with the water and all, all type of copies and all. If you want to note down some screenshot directly. Start on it. Start. Will it work on iPad? Actually, I don't know. I don't have an iPad to test it. I think it should work. If the Hangouts on here should work on iPad, you can have a check. Okay, so I start. You guys can also say something so that I can hear if you guys have any questions like that. I'll be checking the group in the, each and every moment. Okay, fine. So start. It's just about the basics of the Linux kernel and compiling your first kernel. Why I'm instructing. So what is a kernel? In computing, the kernel is a computer program that manages the I/O requests from the software and translates them into data processing instructions. So what it is? Input-output requests. So a user just requests from the software. So the kernel just translates into data processing instructions. Means what should be processed for the central processing unit and other type of the hardware, which is mentioned as the electronic components. The fundamental part or the main part of a computer actually is not of a modern computer system. You can see the kernel is used in each and every device, starting from your fridge, your small mobile devices. I think many of you are, most of you are using Android systems and other systems. The main thing which powers the operating system is the kernel. So now I move to the Linux kernel. During 1991, Linus Torvald developed a kernel to work with his 80386 based computer to try out the new things. So he just started development. He was using AMI-NIX operating system and he wrote the whole Linux code in C, which was new compiler. It was run and it gained a very big fame. And afterward, and many developers started to work on it, and he named it as Linux. So it's not about a very tough thing to learn, but you will enjoy while I instruct you with this. Okay, fine. Now I shift to the function of the kernel. So what does the kernel do? First of all, you can just see the 5 things: the central processing unit, RAM, input output, memory management, device management, and system calls. So what's about the central processing unit? This is the unit, or this is the main thing which controls or is used or responsible for the running or the execution of the program. This decides how many application or how many program will be running and what should be allocated in the processors and which should run in which time. Means if, suppose there are 3 programs A, B and C, so which program should run first, A or B or C? So everything is decided by this CPU or central processing unit. Now again, then I jump to the random access memory. I think from childhood who are just reading the computer, you have came across this term, random access memory, the RAM. It this memory used to store both the program instruction and data. Means how should the program go forward or from one process to another process inside the program, and that data or the volatile data which should be kept for some time during the run, and after that it's deleted. Means not the permanent storage, it's about temporary storage which is used for the execution. Even you can see there are in times there are multiple programs which are running, so the third, so the memory management come into action, which I'll be saying later on. Actually, I am not going deep into this function of the kernel today. It will be in the second section, because today I will be teaching you something else. So now, okay, let's move apart from that. So now I come to the input output, INO. I IO device. What is it? Input output device. Input means for the layman, the mouse, the keyboard. For the output, you can say the monitor and the printer and all. Now, this kernel, what does the kernel do in case of IO? I am just writing something like I am just making a key press of A. So the kernel gets from the hardware that A is pressed, it processes and it says to the application that hello, the person has pressed A. So you just check it, what does A do? And again this application backs what is the coded in the application for the key press A, the kernel gets, and then again kernel makes an execution to the output device like the monitor, and it shows you the output. The memory management. Now I jump to the memory management. Now in the system memory, there's two type of memory. One is the virtual memory, like the RAM. Another is permanent storage, like the hard disk or whatever it is. First of all, the first step is doing the virtual addressing. The virtual addressing allows the kernel to give a physical address for the memory block. Like if you have, I think many of you have learned the C programming language. There, we have learned about how the memory is arranged in blocks. If you have not learned, let me say you, the memory in the RAM, you can think like it's having a building with different rooms. Each room is a block. So we are just parting the whole memory into some blocks. So when one application is in need of some amount of memory, then a block is given for that application. So you can and again another block is given to another application. So there is not a quarrel between the applications who will use which block, and it also manages intelligently which block to give, and the things are done like that. Now I come to the device management. As I have said, when I was discussing with the IO, it can manage the devices. Means when and how the calls from the mouse, how it will be working, when like key press is done in the keyboard, or how the monitor will be given output and all. So let me given briefly about that. On the interface, it will be directly interfacing. It will be controlling the video. It will be controlling the device drives, like the C drives and all, and working with all the types of hardware. On the software side, it will be allowing the operating system to directly allow the hardware. Then it will be interfacing for the non-driver softwares, like that software do not require the drivers. Now I just shift to the system calls. Now we can say in computing, what is a system call? A system call is how a program requests a service from the operating system kernel that it does not normally have permission to run. What do you understand by this line? That is a program which requests a service from an operating system kernel that it does not normally have permission to run. Suppose a software is there which wants to do something, but the system is not giving the permission to run. So it will directly ask the kernel to do, and the kernel will take the information and the kernel will do. So what does it do? It provides a security interface so that the virus and all can't work. That's why we know that the Linux system is not having that many viruses attacks like the other operating systems. We can say it's a type of communication. So the software is communicating with the kernel, and the kernel is communicating with the hardware. So it's a type of communication. Sorry, not a communication, a safe communicational procedure. It can also be said a mechanism that is used by the application program to request a service from the operating system. So these are all the functions of the kernel, which I have just said very basically, because if I say each and everything, it will be taking a lot of time and it will be just going over your head. So I'll be providing you the notes before the second session. Now I come directly to the structure of the Linux. So what you can just see, here's the Linux kernel which is sitting here. Here's the operating system services. Underneath there's the hardware controller, and again in extreme front-end side this use applications like LibreOffice Writer and all. So you can just see from this diagram, the Linux kernel is directly hardware controllers and your web services. So the Linux kernel, the hardware request from the Linux kernel just works with the operating system service, which takes the data from the user applications, which gets back to the operating system service, then gets back to the Linux kernel, which again gives the out of the hardware controller. So here is the IO system is working, and there's the web systems and the user applications. So the structure of the kernel. Now you can see this is a flow chart about the structure of the kernel. Now I come to directly the process scheduler. The process scheduler is responsible for the controlling process to access to the CPU. This controls what process will be controlling the CPU and how it will be controlling it, like a manager. The memory management or the memory manager manages the memory to permit multiple processes to securely share the machine's main memory system or the machine's RAM, so that the machine does not fail because of the overutilization of the memory. It even supports the virtual memory that allows Linux system to process more memory than available in the system. Using that is known as the swap memory, SWAP swap. And the unused memory, which is not used by that time the program, means the excess memory is always swapped out using the Linux kernel, and again it is just pulled back when it is needed, thus giving a more efficient way for using the memory. Now I come to the virtual file system. This is a very interesting part of the Linux system. Like, I can say this is an interpreter. How? I press the word A. So A is a data format. Like, I come to the layman terms. A is a data format means when I press the A, I think A is said in the languages, say it's known as told in Bengali. So the virtual file systems, it will translate into one language, say it's a machine language, and then the memory manager only understand Hindi, so it will again take it from here, the Hindi, and it will be translating into the Hindi. Actually, what I said, it's not that. It makes a uniform file system so that the whole system can understand. This abstracts the details of the variety of hardware devices by presenting a common file interface. It makes a single file interface which the whole system can understand. Means whatever I press in the key, it's Bengali, so it will be converting into the VFS file system. And again, this can be understood when the memory management interprocess communication. Again, when the memory manager is saying in Hindi, it will be converting into VFS file system, and the network interface can understand. So it gets to uniform so that no hodgepodge is created for in understanding. So the communication, the inter-system communication remains good. The network interface, as you know, it deals with the variety of network devices or hardware, network hardwares to control with the CPU and other full system. Inter-process communication. So as I have said, if I just go here, user applications or OS applications. Here one process is running and here one process is running. So we have to just link to two process. So we have to interlink two process. How can we do? So we use this inter-process communication to link two process into one so that it can be worked out efficiently. Now I come directly. How to make your first Linux kernel. So today, what we'll be doing is compiling your first Linux kernel, and then we will be running it in a device which I will be using a Raspberry Pi. So let's come here. The minimum requirement for the compilation is a computer running Linux operating system, which I am running, which is currently using elementary OS. It is a derivative of Ubuntu. Internet connectivity, which will be used for downloading of the scripts or the files. A basic knowledge of C programming, which is used for debugging. Today's session won't be covering the debugging. I will be explaining those in our next session, which will be a bit of more duration, and we'll be discussing about each and everything. So I am not pressurizing to understand many things today. And a device to test the kernel. I won't be testing my kernel in my computer. So first day I'll be teaching in Raspberry Pi. The next day I'll be using my YU Euphoria, and I'll show to compile a kernel for the YU Euphoria. That will be more funny. Not funny. It will have more enjoyment. Okay, let's start. Here I have used elementary OS derivative of Ubuntu as my operating system for demonstration. So, prepare your machine. Open terminal or terminal emulator. Can you guys hear me? Then please write something in the group. Because I think there is having some problem. Because I think there is having some problem. Because nothing is written in the group or the side chats or the question answers. Or even if you have some questions, you can write in the group so that I can just answer you, or in the group chat in the side, if you can just see, you can just group start by clicking on this chat, and then you can just write it in the side. So I can just answer to you directly if you're having some problem. Okay, fine. So this is basically what the terminal is. Now, prepare your machines. First, open terminal emulator. We already have opened this terminal emulator. A second, there are some libraries which you will be needing for the compilation. First of all, the build essential means the essential packages, the kernel packages, live, ncurses, and bzip2. These are the libraries which you will be needing for compilation, which you have to install by this command. I already have installed, so I don't have any problem about that. So I just skip to the next slide. It's downloading time. This is how you have to download. For that, you have to do one thing. You have to check with your computer sudo apt-get install git. So you have to just check the git if the git is present or not, because the git is the main thing which will be requiring. Now we just make a directory called Linux, and then we get in the Linux directory, this empty directory. We initialize a git repository saying git init. Then we just go to my GitHub page. As you can see, github/yajnab. So you'll be getting my page. You can just go to the repository Linux Raspberry Pi, and you can just get this repository by directly copying this command. Let me say the size of this is gonna be about a GB, like that. For that, I'm not downloading this. I'm just canceling about it. Will be taking too long. I already have downloaded it. Here. So let me just demonstrate what it is. After you have downloaded the source, you will be getting all these files. Now let me say what are the folders for. Sorry. I forgot to say what you are downloading actually. You are downloading the Linux kernel source. Means for compiling the kernel, you need to have the main source files which will be compiled by you to make your own kernel, which is using for your device. I come to the first directory, arch. This subdirectory of the Linux contains all the architecture specific kernel code. Like if you get into the arc directory, you can just see alpha, arc, arm, arm64, avr32, blackfin. These are the all types of the architectures. Like if I get on the arm architecture, you can just see these are all things, all types of the arm boards. Like for getting the Qualcomm MSM boards, you can just find the Mac MSM. You will be getting the Qualcomm specific boards. Though we don't have Raspberry Pi BCM280 like this one, Mac BCM. Here the Raspberry Pi files are kept. This now in every in every of the subdirectories you can see there are the configs. Now what the configs. For making the kernel for device specific, you need to have some configurations. Means you have to say what type of the configuration it is having. As I am making for my Raspberry Pi, I have its configuration file saved as gluon. So you can see bcm rpi underscore gluon def config. So this is the configuration file. As you can see, what is it? An automatically generated file. If why it is automatically generated file, I will say you later in my second session. But actually, you can just edit according to your need for making small changes in the configuration if it is needed. Not like that. So you can just see what are the subsystems and all. Everything is in the configuration file. You can edit with your need. So this is a basic thing about the architecture directory. I'm not getting much into it today. Then this include directory. This is containing all type of the inclusion. Like if, all those who have learned Java or C, if you can remember, has import stdio.h like that. If you know the stdio.h and all are called from an inclusion directory. Like you can see all types of the header files are there. Each and every header files are present here. Means all the header files are kept inside the Linux inside this folder include. Then init. This folder contains the initialization code file. If you want to really learn how the kernel works, you should start learning first these files. This brief description will be given by me or Alex in the forthcoming sessions also. At this moment, I am not covering each and everything. Then this IPC, as I have said during inter-process communication, this IPC folder contains all the type of inter-process communication codes. Now, how two processes can communicate between each other. Then there's kernel. This used for the built-in modules. What the built-in modules? I'll be saying you after some time, after 2 or 3 minutes, I'll be saying not 2, 3 more 5 to 6 minutes. Then lib. This contains the kernel's library code. The architecture specific library can also be found in the architecture FAB and its library. Here is all the library files are kept, and here are the library files. So there are two library folders. Mainly this lib library folder is used for the major purposes. So here are the all types of the library files. Let me have a check if people have left any questions like that. Okay, there's a request from Siddharth. If I can send the steps in doc notepad, I'll be, if you can see here, the instructions I have already written, how to do this. I'll be sending you my PowerPoint presentation file, and the same thing will be done for the sharing. So you don't have to worry about that. I'll be sharing each and everything with you guys, starting from the source code to everything. And I don't know what's the problem for the sharing. I think the very bad video quality is there because of our ideas. Yeah, font size is very small, right? Okay, let me have a check. The small font size is small. Wait a minute. I'm just increasing the font size. Wait a bit. I'm really sorry for this delay, which I am trying to fix the font size. This elementary was terminal has really some problem. Yeah, is the font size now okay? Let's see and say. Let's check what you have. Is the font size okay or not? Just say now. What's the problem? If you can share in the group chat, then that will be fine by me. Because otherwise it will be very problematic because I already have increased. Chelsea and Siddharth, I can't understand what's going on. I already have increased the font size. Can you guys hear me? If I increase the font size now, then it will be it will look gigantic. I think the video will be getting loaded in the YouTube, so you can just see from the YouTube and you can just see if you really are having problem at this moment. Let me get back to describe you the function of the other folders. This is a driver folder. This is all the type of the system drivers. Actually, Linux kernel includes all the types of system drivers which are used for driving the system or the controlling of the whole systems. And these are the further divided into classes for the drivers. For the accessibility driver, ACPI driver, ETA, and all the types of the drivers are there. Even if you want to the character controlling CD-ROM, everything is there. Alex will be taking the session how to write the drivers of the different types from him. After that, it comes to the FS or the file systems. This folder is containing all the types of the drivers or all the types of code which are required for making the file systems. The file system, what is the file system? Like 9P, AFS, BFS, the mostly known file systems are like the ext4, ext4, ext3, ext2, even you can get the FAT. There are Microsoft fonts like the NTFS, which are also used, XFS, the F2FS, which is being used these days by the Android devices. This kernel folder, these are the main files which are used by the kernel. Here is the one part, and other part of the devices goes the architecture and new architecture system, and there you again finding a folder called kernel. See, these are the main files for the initialization and how the kernel should work. This net folder contains the network related files. Samples is containing some sample codes for the networking which can help you for the development. The scripts, these are containing the scripts. You can see the very Python scripts, and there are some C scripts, which is a script for the compilation of the kernel. The security is containing all the security features of the kernel. The sound are related all to all the types of the sound card codes and all. The tools are containing the tools which are used while compilation goes, and after compilation the Z image or the kernel. User is a user file, and VIRT is a virtual directory, which I'll be taking you later in my current sessions. Now, this is a script which I'll be used to make you understand how the compilation will be done. Let's see what if. Okay, fine. You guys can hear now. That's fine. Thanks for making me happy about one thing. Oh, now I just shift. In every directory, you can just see there is a make file. The kernel is, now let me say one thing. The kernel is entirely containing assembly files which are which are less in number. Then the majority of the files come in the C programming language. If you know why C programming language, anyone can ask. why the kernel developers have not shifted. There are so many developers. It's not hard for them to write the C programming to shift from one programming language to another programming language. Though there are many programming language like C++, Java, while still we are stuck with C for making the kernel. The answer is very simple. C is the fastest runtime programming language. Sorry, it's not fastest. One of the fastest runtime programming language, which is easier to write. The guys who are you from the computer science engineering department or doing computer science should be knowing that the fastest programming language, like the assembly language, is very tough to write. And the guys who are writing in the assembly language, they even try to write long code for the negligible things of the codes. But in case of the C programming language is easy and the runtime speed comes close to the assembly language. While the C++ and Java, due to their extended features and the object-oriented programming system, the speed of the programming is quite, the speed of the runtime is quite less. So we are just stuck into C, and the make file is the instruction files. Like the if else command and which file to compile and which file to not, and at what condition which file to compile and which file to not. Use the function to make file. So we just get into our build script. These are build script. Thanks, the size is already big. I just come to here. The kernel, actually, when you are compiling the kernel, there are basically three things which are produced. First of all, I need to tell you two things. First thing that is compiled is Z image. Like I have said, making the Z image the real deal. The Z image contains all the code types of files which contains the INIT codes and all, which are used for the first initialization of the program, and the drivers which are all time loaded. The second thing which comes are the modules, means the drivers which are used when in need, which are not active all the times, and which are used only the purpose when in needs, and they are all kept in the module directory after the compilation. And third thing, that is the DTB, sorry, DTS or the DTB. As you can see of this extension, these are the device tree files, means the files which are containing the information about that device, which is a very new thing in the kernel, which is started in a very later stage, that is kernel 3.4 plus. So first we are just saying this just is specifically a shell script where I have written each and everything, which I will be just starting to demonstrate. First of all, okay, you come started u1.sh. You can just see this is a banner. The cleaning, making the JDM as a real script. Just see what happens. These just compiling each and every C files which are there inside this kernel directory, and our configuration have said to compile this and these drivers. The things we can just see security keys permission.o. This is a driver, and again the kernel CPU driver, and the CC in the third bracket, the M refers to the modules, means the drivers will be packed in the module, and without that the drivers will be packed in the JD image. So this will be taking about a lot of time to go. about 15 to 20 minutes. Means it's just 8:54. It will be taking about half an hour more. So you can just chill and you can just sit over there. Let's see what questions if you have put. Okay, Chelsea has written 5 browser का भी use कर रहे. Okay, I think the next session I have to use some magnifier. I really didn't know that this can happen for demonstrating. I think if you this will be recorded in the YouTube, you can just check out later what are the things written with the using a 720p. So it'll be just useful for you. It'll be taking about a huge time, about 20 minutes. You can get a cup of coffee if you guys can want. See, the file systems are also being compiled at this moment. So in this time, I come to the group. So what are the problems which you have faced till now? There are some sessions still which are not over by this time. Okay, I forgot to say you guys one thing. The kernel which you are compiling, it's basically for a device called Raspberry Pi. This is a device, the Raspberry Pi. Let me give you a screen peek to the Raspberry Pi. The Raspberry Pi, you can just take a look at it. It is a very tiny device powered by ARM V6 processor. Very low configured device, but it's a very useful tool or a very useful computer which can help you with the debugging and these steps. So I can get back to my screen sharing. You guys can see it's still getting compiled. It will be taking a huge lot of time. I don't know why no question and answer is coming till time. I don't know what the, audiences are doing because there is only 2 viewers at this moment which have dropped from the 6. One thing, let me say to you guys will be facing many problems because it's very difficult to demonstrate how to do all the things with very low speed internet, which I think you guys are having. And also in my case, I am not having it here at Kolkata, which I just came today. Is it being making problem? My internet speed also, so I don't know which is actually the problematic. Siddharth is constantly saying that he can't hear me. I don't know what's the problem in the hearing. Let me check my sound setting. If there's a problem, you guys can hear me? Yeah, yeah, everything. Okay. Rohan said, the all information of chipset and all are present in the source, then how do kernel source differ? How the kernel source differ? Actually, see, our main kernel source. Let me show you something. Kernel.org. If you just go into the link of the kernel.org, you can just see there are the many types of supports which are containing each and every files of the kernel. But again, why the different manufacturer make their own kernel and they ship their own kernel? Now let me take an example or YU. Why you are making two devices like YU, Euphoria, YU, Eureka, and the main Linux distribution only supports there a few types of chipset, like they're supporting a chipset of Qualcomm 310. I'm just saying, but this Euphoria is supporting a kernel of 8 chipset of 8. So like the memory management code, I let's suppose I take an example of this file. I get into the drivers, and for the FireEye drivers, I think the core card. I get, suppose this is a file. Now this file can be used by both of them, but in a different manner or a different code. So what is the different code is? The different code is, I can, one file requires some of the function while the other hardware requires other some other functions. You can just basically keep both the systems, but it's good if I just keep them in other side. Now, by different device, use different drivers. Okay, let me say the different devices use different drivers for the controlling of their devices. Now, suppose I take two devices, A and B. A is using the same file and B using the same file. If you just keep these two, can you guys hear me? I think my device is making some problem. Okay, let me reply to Rohan in the Hangouts group itself. Yeah, I'm just getting jumbled by several questions from the sides. Actually, the decision is taken by the manufacturers and the developers. to keep each and everything in isolated states. What you can say by isolation? Because the many developers work in the Git. The developers from the outside are working on one code, and developers from the another source is working on another code. So there can be a mismatch in the developer, and one developer can make their own inclusions, and from another side there can be made another inclusions. So there can be a mismatch while running, and the code can get buggy. We just keep those isolated. If you just see in many of the Git of many developers, the developer keep on constantly merging those upstream commits. The upstream is the main upstream of the Linux. The upstream can be upstream of the Qualcomm, which is hosted by the CAF. So each and every developer is just keeping them inside to keep the work safe. You can say in one thing, and other thing to keep the code safe so that the mismatch is not there and the bug is less. Actually, a genius man, really a genius man, and well organized man can use a single source to keep up to crores of devices. If you can really keep them in isolated, you can just really keep in only one source. There's no need for the differ in the sources. The manufacturer are keeping because they don't want to make a hodgepodge everything the source. Then the source would get big, and more requests will be there. And as you know, the organizations always try to keep themselves in isolated, means only YU people will work for YU, he'll be working from him, like this. There's nothing about that the kernel source differ. The kernel, we make the kernel source to differ. Actually, if you want, you can merge each and every device source into the one kernel source, and you can use it. There are problems. There will be a big headache for you. How can I manage this and how can I manage that? Because there will be overlapping of the things. To avoid those situations, the things are like done like that. I think I am clear to you, Rohan. I'm waiting for the further questions. Minimum requirement for what? Vishal, you want to know the minimum requirement for which thing? The device for which you are compiling. It can be anything. If you just know, even the latest watches are using the Linux kernel. Even I was just working with a guy in my school life. He was successful in implementing a kernel for his microwave. Okay, the device in which you are compiling kernel. Actually, there is no minimum requirement. The time requirement will be more. Like if you have a high-end PC, like I am just using the Core i7 laptop in which I am demonstrating you guys. It's taking about 20 minutes to compile one kernel. If you just compile it in the Raspberry Pi, it will be taking about 2 hours. There is not any minimum requirement. Just you have to keep one thing in mind: how many cores it is having, and one thing I should say that at least 512 MB, 256 MB RAM with a Pentium 4 processor will be good. Because if you just go back and check in what system Torvald he himself developed, it is very underpowered system. 8036 processor, you even can't imagine what underpowered system it is. But nowadays, like the 3.18.12 kernel, which I am just compiling, it's very upgraded kernel and it's having a lot of drivers. Like you can see per second one driver is compiling, but how many drivers and modules are there? So the minimum requirement should be a Pentium 4 machine with 512 MB RAM. It will take about 1 hour to compile for Raspberry. One thing. Wow, okay, very good question, Rohan. I'm very happy with these questions. I would have discussed it in the next session. Okay, as you have asked me this question, if an Android device source are closed, is it possible to make a kernel for device? If yes, how? Actually, what I have, what I am seeing from my first uh, time, that are the things which are present in a kernel. The kernel comprises of the multiple drivers used for the powering up of the device for the inter-process calls and other type of the structure. If the thing is closed, how can you basically make a driver? You just can't make an arbitrary driver and make it to power that system. If it is closed, and if you are genius and you know how to make the driver work, you can really make it. And if the source is closed, I should say you can't make it. I should say you can't make it unless and until you are a genius. Waiting for the next question. Anyone having any more question? There is a problem with the Chelsea. He's saying it took 40 minutes in a dual core laptop and PC took 7 minutes. Chelsea, both the devices for which you are compiling were same. How to add features? Chelsea, that will be dealt with Alex. And in my fourth video session, I'll be teaching you how to write the basic drivers. So by that time, I will advise each and every one of you to learn C programming language. If you want to know about what books to follow, I will just mail about that. I will just not include about the author's name and all, because it'll be it's not good to say the publicly about the author name and all. I'll be saying about that, and I'll be sending you some notes, and you can just get them. And you can see that the things are constantly being compiled and it's taking a lot of time. While in the next session, I'll be teaching compiling the Android kernel, which will be you will be compiling your kernel from the YU Euphoria, and I will be showing how it is running in Euphoria. Today, it will be run in Raspberry Pi, and you can see that my compiled kernel is running in the Raspberry Pi. By tomorrow, 5 o'clock, you will be all getting a PDF file, how to do what inner writings. So you can just make and submit your assignment. The next video will be on about 25th or 26th. I'll see you that later. It will be on 25th or 26th. Or after 28th. Charthia, by feature. Oh, okay. You mean to say you want to add the governor IO cellulars, OC and UV. Today I'm not dealing with Android kernel. Have I a single sentence was made Android kernel? Android kernel is a bit, I am saying a bit different from the Linux kernel, because there are more drivers which are added by the Google while development of the Android systems. I will say what are the things which are in the Android system. Achit, for the assignments, I'll be saying, I'll be mailing you all by tonight. So I have asked you all to do a thing. Mail me your email addresses so I can just forward all you guys. or I'll be just putting it here about the assignment. It will be just simple. You will all have just to compile one kernel for this Raspberry Pi, and I will be checking, and whose kernel will be not working, I will be just letting him know that your kernel is not working, and all the steps. That's not very big. You don't have to do it. This, the labor is very less. More questions. I am waiting for the questions. Yeah, you can just see the compiling is done. The compiling output. What you get in the output? That's basically in the ARM boot. Here are the things which are getting it output. The Z image file. The file that is a Z image is the main thing of the kernel. And then the DTS Z image containing all the drivers which will be active all the time. The DTS is containing all the types of device tree files. I have just made the script to sort out each and everything into output directory. Output directory boot file, you can see all the DTS files. The kernel.img is a converted Z image into the kernel. The overlays are again containing the DTP files. These modules are again containing, if you can see, all the types of the module files, all the modules which are compiled. It will be there in the writing, and you can understand yourself when you just compile any your own PC, the Raspberry Pi. That's why I said that it is better to compile for a computer related thing before you are just compiling for a device, because you can just see the isolated file systems. Now let me come to the script. Okay, I just made a mistake. These are the things we be getting the output. Now let me come for the script which was used for the during the compilation. Just time. This line is used mainly for the making of each and everything of the DTS, the Z image, and the modules. Now, what is the time? The time will give you the what time it took for execution of the command. R equal to R means your the device which you are compiling for is actually of the ARM command. Okay, I missed the previous line. Arc called to ARM is architecture is ARM. The cross compiling. This is a part of the tool chain. Now, what is a tool chain? I was just waiting for this moment. Tool chain is a set of distinct software development tools that are linked, or you can say it's just a toolbox where each and every type of compilers is present, which are used for compiling a tool chain. You can just obtain the tool chain here. I have just uploaded the Cybermall tool chain, which I have used for the compilation in this link. This is a path of the tool chain. Make J64 means it's actually, I don't know, I just made a mistake while compiling. You should make J4 means at a time 4 threads will be used. This thing you should say after the J4. 4 means or the JX. This numerical code should contain twice the number of cores you are using. Means if you are having a single code machine, you should write J2. If you are having a dual core, you should write J2. What happened to Chelsea? I think as Chelsea said that his laptop took more time than his desktop. It many time happens that your device, some other process is taking a lot of memory than your main process and it's consuming a lot of CPU. If not, then this command is just wrong that your PC more processors are being used by the JX, where the X in your PC was more than the X in the laptop. You can just check it by the make J4 in your laptop and PC, and you can just compare which is faster. And the config debug session mismatch, this is something else which I'll be dealing with in my next videos. I mean next sessions. And the second line, install mod path. In the mod path of the modules, the modules are made which are installed in the modules path. As you can see, I have just said by the modules. Okay, means this type of modules are kept here. The modules are kept here. If you can just see, these are the compile modules. And again in the tools, this is just to convert the JD image to Kernel image using a function mkknlimg. And here the compile things are there. So I have basically what I have done, I have just compiled the thing and I have already put it into my Raspberry Pi. I'll be showing you with the help of it. I'm just powering on my Raspberry Pi, which is connected with UART. If you just want to see, I have just connected my Raspberry Pi with soft with a device called UART. This UART device which are connected with the Raspberry Pi, so you can just debug the Raspberry Pi as you just want it. Screen share, present to everyone. Okay, I'm just sharing. I'm just turning on my Raspberry Pi. This putty is a software which is used for these all tasks to connect to a serial interface. Now, UART is just a type of serial interface with which you can debug devices which are not having the ADB. In case of wait for some time. You can see I have just logged into my Raspberry Pi, which is running, and I think the font size is very small in this case. I will be showing you the screenshots. You can just see the Linux version 3.1. If you can just see it, that is just the thing which I have just compiled. The Linux which is compiled. And by this I end this. Okay, that's I end my full demonstration.